Hello everyone, I am Sanketa Satish Mahale. I am currently doing the internship in Emertxe Information Technology on embedded system. And during this internship, I built a project based on MPLab X IDE and simulated the software name is a PixSim Lab tool. And I am here to present the microwave oven project as a part of my internship at Emertxe Institute. This project demonstrates how embedded system can be used to control the operation of the microwave oven using the microcontroller. And the contents of these projects are topics learned during the internship. What is a microwave oven, microcontroller and the microprocessor, PixSim lab tool, CACE, matrix keypad, ISR timers. At last, we will go about the project implementation. First one is topics learned during the internship. We learned the introduction, the C language, like the basics of data types, syntax, and then arrays, pointers, functional strings, storage classes, and the conditional loops and operations. Then we learned the introduction to embedded system microcontroller, MPLab, XIDE tools, PixSim lab tools. Then introduction to the various peripherals, then attended the multiple quizzes. Then, then what is a microwave oven? The microwave oven is used to heat the food using the electromagnetic waves. There are the various modes in the microwave, but here we are considering the three main modes. One is the micro mode and the grill mode and the convention mode. This mode, first one, the micro mode is used to cook the food in a traditional manner. The maximum we can set the power up to the 900 the watt. Then grill mode. This mode is used to cook a meat and the bread. We can set the time accordingly. Then convention the mode. This mode is a user can set the oven free heat for a particular the temperature and the user can set the time accordingly. Then the last one is in a start mode. It is to start the microwave. Here see the picture. There is a micro mode and the grill mode and the convention mode and the start mode. Then the what is a microcontroller and the microprocessor? Microprocessor are the CPU is a stand alone and the RAM ROM input and the output timers are a separate. But in a microcontroller, CPU, RAM, ROM input and output are integrated in a single chip. Microprocessors are the high processing the power and the high power consumption compared to then the microcontroller. And then microprocessor have the it is a use for in a general purpose, but the microcontroller are the use for the in a single purpose. Then go about the PixSim Lab 16F88A78 tools. PixSim Lab is a virtual laboratory that allows us to simulate the microcontroller project and particularly those based on the PixSim F8 in a 77 microcontroller. And it is a powerful simulator that makes the learning embedding the system easier and the more attractive. See here the picture one. This is the PixSim Lab 16F8778 tool. We can see the software tool on a system or the laptop. And then picture 2, here that is the PixSim Lab 16F877A, the pin diagram. Then go about the CLCD. Full form of the CLCD is a character liquid crystal display. In the CLCD, it is used to display the 16 into 2 or 16 into 4 LCD display. It have the in a two communication the mode. One is a 4-bit mode and in a 8-bit mode. Then the matrix keypad. This keypad in which the number of tactile switches are connected in the row and in the column concept. Then ISR is a interrupt service routine, means software routine that hardware in a response to an interrupt. The interrupts are in a mainly plays the roles in a microcontroller, means interrupts is a communication process set up in a microprocessor or the microcontroller in which an internal or the external the devices requires the MPU or the MCU or the stop the processing, means that when the signal that temporarily the stops the normal execution of the program to attend to the urgent tasks. It is a way for external or the internal device to get the attention of the processor. Once the processor receives the interrupt, it pauses its current work, then handles the interrupt, the request, and then returns to where it left off. Then the last, the timers. The timers is an important application in an embedded system which is a default peripherals which maintain the timing of an operation in a sync with the system clock or an external the clock. In this project, I use the 4-bit of the timer. Let's discuss about the output of the project. I have attached the some of the output screenshot. First one is the power on. This is the power on. Um, Power on screen. As soon as I load the hex file, then screen will be displayed. Then the second one is a display of 4 mux, and that will be a display. See here the micro mode, grill mode, conventional mode, and the start mode. And then micro mode, I already said we can set the time maximum power up to the 900 the wax. Then the grill mode we can set the timer accordingly. Then the convention mode, after the setting the timer, it will give us the option as a start and the pause. See here the start and the pause. Then this screen appear as soon we press the RB3, means um, when we press the button then screen will appear. And thank you, this all about the project. Now let's move to the actual simulation of the project and the code. So this code is written by me. Let's see the simulation here. First of all, we have included all the libraries in which required to. Then we have provided all the types of all the variables initializations. You can see it here. We have provided all the variables initializations, and we have initialization the models that is required. Here we are using the while loop to mention the project, which is specify the different the conditions. So for example, if we press the key 1, as then what it should display it is mentioned over here. If we press the key 2, what it will show it will be displayed over here. So for all we have written it. Also we are using the switch case to determine all the conditions. All the cooking modes in it. We also declared all the functions that is required in the main file. Now coming towards the end. So everything mentioned in a while loop. So our code will run or Coming towards the main file, we have included all the prototypes and all the modules that is required. Now let's build the project and see what's the output. As you can see, the build is successful. Now let's see the simulation in a FixSim lab. I will load the hex file. So as soon I load the hex file, power on the microwave oven screen will display this is shown as a CLC display. Here is the fan as soon as switch on any mode. I displayed as soon as switch can only mode the cooler or the fan will run. So we can choose any button, anything, and it will display the output. So buzzer is there is that's why why it is not working as soon as we press the buzzer. Here it will start working. As soon as you can see, I have the first chosen the convention mode. So here I am getting the option to enter the temperature. I will enter the temperature, set the temperature. You can give any number of that. You can clear with the help of star and enter with the help of enter. So preheating the time we have given 180 seconds. That is a set. While written editing, writing the code, it was set to 3 minutes. So it will go on. So you can reset it from here. You can do the reset. If you have by mistakenly press the preheating mode, you can reset it from here. And again power on screen will be generated and you can give the command. If you would have liked to press any button, that is a micro mode, or any, you have to press RB4 button and then you will get all the 4 option here. You can choose any button that will generate the code. So this is all about the microwave and that we have generated. I would like to thank Emertxe Technology for giving us the opportunity to build such a project in such a short plan of time. They have given us all the feedbacks how to build the project and the taught us to how not to build the project. Thank you so much, Matrix Technologies.